Everyone, for today's lesson we are going to learn about inverse functions, but before we do that I would like you to please go ahead and complete this really quick warm-up where I would like you to solve each equation for the letter y. That means get y alone. The first equation is 3x minus 2y equals 10, and the second equation is negative 3x plus 4y equals 7. Please go ahead and pause the video and solve for y for each, and when you have an answer, please restart the video and we will see how well you did. All right, let's go ahead and see how well you did. For the first problem, we need to get y alone. So what I'm going to do is I'm going to subtract 3x on both sides. And by doing that, the 3x's will cancel out, leaving me with negative 2y is equal to negative 3x plus 10. At this step, I'm going to divide every single term by a negative 2. And when I do that, my final answer will end up being y equals positive 3/2 x minus 5. For the next one, I want to get y alone, so I'm going to start off by adding 3x to both sides. And when I do that, the 3x's cancel out, leaving me with 4y is equal to 3x plus 7. If I want to get y alone, I'm going to divide by 4 on both sides. Every single term will be divided by 4, and I'm left with y is equal to 3/4 x plus 7/4. So hopefully these two problems were pretty easy for you, and if they were not, please make sure that you come and see me during my extra help sessions after school or before school. This skill of getting a variable alone is going to be a skill that we are going to use in order to identify the inverse function of a given function. So our learning targets for today is for you to be able to say, I can find the inverse of a function algebraically. That means that we're going to be solving for y just like we did up here. Then I want you to be able to say, I can use compositions to determine, so that means that you're going to make a decision, determine whether two functions are inverses of each other. So if we're working with compositions, that means that we're working with that f of g of x and g of f of x concept that we just learned in our last lesson. Now, please recall what a function is. We talked about this a little bit in the beginning of the year. But before we even talk about a function, we need to talk about a relation. And what a relation is it's a pairing of different variables. It's a pairing of our input values with our output values. It's a pairing of x values and y values, where your x values represent your inputs and your y values represents your outputs. So it's a relation is a pairing of x's and y's, and that's what we write that as ordered pairs. So whenever you are plotting a bunch of ordered pairs onto a graph, that's considered a relation. A function, however, has a specific definition. It's a special relationship between all of the ordered pairs. And what you'll see in a function is that each input has exactly one output. So it's where each input, or x value, is paired with only one output value. And we talked about that when we did piecewise functions at the beginning of the year. In order for us to determine whether or not a function was considered, or a piecewise function was considered an actual function, we needed to establish that every input had exactly one output. The x values cannot repeat, but the y values can. That was something that we had talked about before. Now, an inverse relation, if you think about inverse, a lot of people think of the word reverse whenever they see inverse, and we're essentially doing the exact same thing. An inverse relation interchanges or switches or reverses the domain and range, or the input and output values. Of the original relation. So what that means is that the domain and the range interchange. So what I'm going to give you is I'm going to give you a bunch of ordered pairs, and in order for you to identify what the inverse function of it is, all you have to do is switch x and y. That is it. So some things that I want you guys to know is that I'm going to give you guys ordered pairs, or you might see something that will have ordered pairs with it. And in order for you to identify what your inverse relation is, all you're going to do is switch your x and y values. So I have right here a relation. We have 0, 6, 1, 4, 2, 2, 3, 0, and 4, negative 2. And those values are plotted right here. So here's 0, 6, 1, 4, 2, 2, 3, 0, and 4, negative 2. They are identified right here. And we could draw this as a line if you would like, if you want to, or just being able to visualize it, that's fine too. And the inverse is essentially a reflection of the function that's given to us across the line y is equal to x. So if you look at where 6, 0 is, 6, 0, so I'm switching around, the 0, 6 becomes 6, 0, that's located right here. And these 2 points, 0, 6 and 6, 0, they are equidistant away from our reflection line. So we have 6, 0, and then 4, 1. 4, 1 is located right here, and it is reflected across from 1, 4. Then we have 2, 2, which is located on our line of reflection. 0, 3, so here's 0, 3, and that is reflected across 3, 0. And then finally, negative 2, 4. So we have ourselves a reflection. So remember that when we were in geometry, we learned about a reflection. A reflection across the line y is equal to x. And we said that if you have x and y values, they turn into y comma x. And this concept will come into play in this chapter. The other thing that I want to make sure that I note is that how do you know that something is a function? Well, if I were to draw a line going through all of my points, every input had exactly one output. Same thing with right here. Every input had exactly one output. So I want you guys to write down that if a graph passes the vertical line test, also known as a VLT, then it is a function. All right, the graph of an inverse relation, like I just said to you right here, is a reflection of the graph of the original relation. And that reflection line, once again, is y is equal to x. So to find the inverse relation given by an equation given to you in x's and y's, all you need to do is switch the roles of x and y and then solve for y. And that's exactly what we are going to be doing. So if you wanted to identify a new equation, so you're given an equation and you want to identify the inverse of that equation, all you have to do is switch your x and y values and then solve for y. And that's where our skill from our warm-up will come into play. So there will be questions like what I'm about to show you on your test, so I'm going to put stars next to it. And what we want to do is we want to identify the inverse of a given function. So sometimes, if necessary, if you're given a problem that starts with f of x, I would recommend strongly that you replace f of x with the letter y. This will be a lot easier to work with if you do that. Otherwise, you're going to get confused about what you're actually solving for. So that has to be the first thing that you do if you are given an f of x. Next, I want you to switch your variables x and y. The y becomes the x becomes the y, and from there you're going to solve for your new y value. And whenever you solve for y, you have to make sure that you simplify your answer. That is very, very important, that you simplify as far as you can. And then as soon as you are done with solving for your new y and everything has been simplified, you replace f to the negative first power of x with y. I'm sorry, you replace y with f to the negative first power of x. So this part right here is very important because this f to the negative first does not mean negative first power. This negative first power actually indicates something completely different. It means the word inverse. So the f to the negative first power means the word inverse. So I'm going to be looking for you to replace your y value with that f inverse of x. So you need to make sure that you have an f inverse of x as your final answer, even if your problem started off with y equals. So this has to be your last stop. Please make sure that you remember to change your y value to be f to the raised to the negative first power of x, because this means the inverse function of x. So let's go ahead and look at example number 1 and actually identify what these inverse functions are. So looking at number 1, we want to find the inverse function. All right, I'm going to give myself a line of space. And in order for me to solve this, I don't have to replace f of x with anything, since letter A does not start off with an f of x in it. So what I'm going to do is I'm going to switch my x and y values. So that's going to be my next step. I'm going to switch my x and y values, so I'm going to write x is equal to 4y plus 2. And at this step, I'm going to solve for y. Because whatever my new y value becomes, that's going to be my new inverse function. So from here, I'm going to get y alone by subtracting 2 on both sides. And when you do that, you end up with x minus 2 is equal to 4y. And then I'm going to divide both sides by 4. And when I do that, I end up with y is equal to x minus 2 over 4. If you want, you can change this into x over 4 minus 2 over 4 and simplify even further. You don't have to. This is a fine way to finish your problem. But now that y is alone, I need to replace that letter y with f inverse of x, because that establishes the difference between our original y and our new y. So this is my new y value. So my new y value. So to make sure that I establish that this means something different, I'm going to rewrite my answer as x minus 2 over 4 is equal to f inverse of x. And that is my answer. Next, let's look at letter B. Letter B, I have f of x is equal to 2x to the 4th power, and I'm given a condition that x needs to be greater than or equal to 0. 2x to the 4th power is an even power, and we know based on our work in chapter 5 that any types of functions that have an even power will have n behavior both pointing up or both pointing down. And because of that, we're going to have we need to limit how much we're going to be working with. So what I mean by that is, in order for a function to have an inverse, it needs to pass what we call a horizontal line test. And that's if you were to graph, like, so I have let's pretend as if wx to the 4th power looks like this. An inverse function is going to be a reflection across the line y equals x, which means that our graph would look something like this. If we were to graph it, this would be the inverse, this is the original. In order for it to pass the horizontal line test, that would mean that it can only pass one point at a time. I'm sorry, excuse me, this is the horizontal line test. It needs to only pass one point at a time in order for it to have an inverse. Because the horizontal line test would go through multiple points, that would indicate that the function as written would not have an inverse. So in order for us to actually talk about it having an inverse, what we need to do is we need to limit it. So x is greater than or equal to 0 means that I'm only talking about the positive side of the graph. So whenever we're solving these equations, whenever we've had like an even root and whenever we've had an even problem and we've taken the even root of both sides, we've always had a plus or minus as a part of our answer. This x is greater than or equal to 0 is telling us from the beginning that we're going to be working with the positive part of our plus or minus, not the negative part. So I know that that sounds like a lot of explanation. This is all that I want you to do. First of all, replace f of x with y. So we have y is equal to 2x to the 4th power. Now I'm going to switch my x and y values. X is equal to 2y to the 4th power. From here, I need to solve for y. So that's exactly what I'm going to do, solve for y. So I'm going to divide both sides by 2. So I have x over 2 is equal to y to the 4th. And now I'm going to raise both sides to the 1/4 power to get rid of the 4th power. This is an even root. We know that whenever we're solving equations and we have an even root, we would have plus or minus. But because this is an even root and we don't want to work with plus or minus, we need to figure out if we're working with plus or minus. That's where the condition comes in. So for here, my answer is going to be simply x over 2 raised to the 1/4 power is simply equal to y. If you want to remind yourself that you're working with a positive, put a little plus sign there, but you don't have to. Since we got y alone, this is my new y value, I need to replace it with the inverse notation. So my answer is going to be x over 2 raised to the 1/4 power is equal to f inverse of x. And that is your final answer. All right, let's go ahead and look at letter C. For letter C, this is once again going to be an even function, which means we have to restrict the domain. The restriction on the domain will always be given to you, so please know that. If it's not given to you, then that's your indicator that you will not have an inverse function that you can work with. But in this case, because we have a restriction that says x is less than or equal to 0, this indicates that we're talking about the negative side of the graph. So in our plus or minus, we're actually going to be working with minus. So I'm going to start off this problem by replacing f of x with y. So I have y is equal to negative 10x to the 6th power. Then I'm going to switch my x and y values. So I have x is equal to negative 10 times y to the 6th power. I need to get y alone, so I'm going to divide both sides by negative 10. And when I do that, I end up with y to the 6th is equal to x over negative 10. I need to get rid of this 6th power, so I'm going to raise both sides to the 1/6 power. And since that's an even root, normally we would have plus or minus as a part of our answer. But in this problem, we're just going to be working with the minus. So my answer is going to be negative x over negative 10 is equal to y. This is my new y value. So because this is my new y value, I cannot leave it the way that it is because it is different than what we started with. So I'm going to replace my y with f inverse of x. So I have negative x over negative 10 is equal to f inverse of x. Now a lot of times, raised to the 1/6 power. Now a lot of times kids will want to distribute that negative in. You can't. And the reason why you can't is because of the fact that we have this 1/6 power. And according to the order of operations, you have to take care of exponents first before you multiply. So you cannot multiply first and then take the exponent. That's one of the misconceptions that a lot of kids have, so I just want to make sure I put that out there. Let's go ahead and look at letter D. Letter D, I would like you to please do this one on your own and pause the video. This one is a little bit easier. It's an odd function, and when it comes to odd functions, we will not have any sort of restrictions on our domain. So it's only those even ones that you'll have issues with. So please go ahead and pause the video, solve this one on your own, and when you have an answer, please restart the video and we'll see how well you did. All right, so like I said, this is an odd function. And odd functions are nice. You don't have to really do a lot of thinking. There will be no plus or minus or anything awkward like that. So I have y is equal to 3/4 x to the 5th power plus 5. From here, I'm going to switch my x and y values. So we have x is equal to 3/4 times y to the 5th plus 5. I need to get y alone, so I'm going to subtract 5 on both sides, and I end up with x minus 5 is equal to 3/4 times y to the 5th power. And then from here, I'm going to get rid of my 3/4 by multiplying both sides by 4/3. going to distribute the 4/3 to each term, so I have 4x over 3 minus 5 over 3, and that's equal to y to the 5th power. I'm sorry, that's not 5, that's 4 times 5 is 20, excuse me. So that's 20 over 3. From here, I need to get rid of the 5th power, so I'm going to put parentheses around both sides and raise both sides to the 1/5 power. And when I do that, I end up with y is equal to, if you want to combine this into one fraction, you can, but you don't have to. This is going to be 4x over 3 minus 20 over 3, all raised to the 1/5 power. And so now that I have my y alone, my final answer is going to be f of x, or f inverse of x, my little inverse symbol up there, is equal to 4x minus 20 over 3 raised to the 1/5 power. You can have your answer looking in both ways. I do not care, as long as it's fully simplified. So one way has where I've combined it all under one denominator. The other way is where you have two separate fractions. They both mean the exact same thing. Let's go ahead and move on to the next page. This is our last example, and then we are finished with this lesson. So how do you know if two functions are considered inverse functions of each other? So in order for you to know whether two functions are considered inverses of each other, we're going to use compositions. If you notice that if you were to take g of x and then take the f of that g of x, the answer will end in x. Or if you have f of x and you take g of that f of x, the answer will end in x. If both are true, then we can say that both functions are inverses of each other. So I'll say that again in a different way. Once again, if you have two functions and you want to know if they are inverses of each other, in order for you to do that, you have to look at their compositions. You have to take f of g of x and g of f of x. If both, when whittled down and simplified, leave you with nothing but the letter x in both situations, then you can say that these two functions are inverses of each other. So that is what this little box up here is trying to say. I cannot emphasize both must be true in order for them to be considered inverses of each other. A lot of kids will only check one but not check the other, and then they've lost half credit for that problem. So what I'm about to show you is what I'm going to be expecting to see on your homework as well as on your next test. So I want to show that f of x equals 4x plus 2 and g of x equals 1/4 x minus 1/2 are inverse functions of each other. Once again, must show both compositions and show me the little work that's involved in simplifying these functions as well. So remember that f of x equals 4x plus 2 means that we're taking f of something is equal to 4 times something plus 2. And g of x means that we're taking g of something is equal to 1/4 times something minus 1/2. And that will come into play when we are checking f of g of x and g of f of x. So I'm going to start off with f of g of x. So g of x I know is 1/4 x minus 1/2. So I'm going to write f of 1/4 x minus 1/2 is equal to 4 times 1/4 x minus 1/2 plus 2. All I did is I replaced this function into my f function. From here, I'm going to simplify by distributing. Remember that every whole number is a fraction over 1, and you can multiply straight across. 4 divided by 4, or 1/4 of 4, is equal to 1. So this is equal to 1x. 4 times 1/2, or half of 4, is 2. So this is minus 2. Then we have a plus 2 on the outside. Negative 2 plus 2, that cancels out. They cancel each other out, and we're left with simply the letter x. So we have just shown that f of g of x simplified all the way down to the letter x. Cool, that's one. We need to show the other one, which is g of f of x, also whittles down to equal the letter x. So since f of x is 4x plus 2. I'm going to replace f of x with 4x plus 2 and substitute this whole function into my g function. So that's going to be 1/4 times 4x plus 2 minus 1/2. So distributing that 1/4 to each term, 1/4 times 4 is going to be 1x. 1/4 times 2, that's going to be 2 over 4, which is 1/2, so plus 1/2 minus 1/2. 1/2 minus 1/2, they cancel each other out, leaving us with just the letter x. So that means that g of f of x simplifies to just the letter x, and that's exactly what we needed. So because we have shown that f of g of x and g of f of x both simplify to be the letter x, we can therefore say that f and g are inverse functions. And that is the end of today's lesson. If you have any questions over anything that I talked about today, please make sure that you write down your questions on your discussion notes, or you can email me if you have any questions. That's another great way to make sure that your questions are addressed. Otherwise, I will see you next time.